In this video, we're going to finish off the console by bringing it into Unity and attaching the materials appropriately. So let's click on New in Unity Hub, choose the correct version. I'm targeting 2019.4.x. We're going to choose a 3D project, and let's call this Console Asset Test. Here's our scene view. It might look different from yours, and that's because I have the background turned off. If you would like to toggle the skybox, you can do so here. I'm going to right-click in my scene view. We're going to go to Import New Asset. I'm going to find the console asset and import that in. This will bring in the model, and importantly, the inspector is going to show details about a model, not a game object. Remember, it's a two-step process bringing in external assets. Unity loads that information in, and based upon the settings you choose here, it is going to process that object and then create the version that Unity has internally. Therefore, you need to be aware that what you export is not truly what you have inside of your game. It will go through all these different options that you choose. So what I'd like to do is drag this asset now into my scene view and hit F. Now I want to do a sanity check. And what I'm noticing is that I have a rotation of 0, but I have this weird scale of 0.3. I like my scales to be 111 when I have an asset being brought in for the first time. That means it's at the appropriate and approved scale for the project. And then within the project, if I need to modify it or make it larger or smaller, say for a giant or someone else, I can do so without having different versions of the asset, and I always have a baseline size of 1 that I can work with for a human being. To fix this, you could come over here and try to mess with the scale factor, but I really recommend, if you can, just coming into Blender and opening up your asset again. Take a look at your asset and open up the item portion of this object. And what we want to do is, because this was an export, I want to choose console on the top, and you'll notice I have this scale factor of 0.34. I'm going to hit Control and A, and I'm going to choose Apply Scale. Now you'll notice that my scale is 111. I'm going to go down to the child objects, and once again hit Control A, and I want to Apply Scale. You'll once again notice that the scale has turned to 111. Control A, Scale. Control A, Scale. Control A, Scale, and so forth. I'm going to select my entire console object, go to File, Export, FBX. I'm going to export this out as console_02_ fixed scale for now. I'm going to choose Selected Objects, going to Apply Transform, going to open up Geometry and turn on Tangent Space and hit Export. I'm going to come back over to Unity, and I'm going to delete console01, right-click, Import New Asset, and choose Console Fixed Scale, drag it into my scene, delete this old object, take a look at it. My scales look nice. Let's do a sanity check by going into Game Object, Create 3D, and Cube. Looks proper in terms of scaling with a 111 cube. We'll take a look now at our model. Scale factor's fine, 1 centimeter's fine. Everything's good there. We'll take a look at our materials. We'll notice that there is a material attached to this object, but it's embedded with the FBX. If we want to modify that material, we either need to create a new one or we need to extract it. I'm going to click Extract. Here in this object, I'm going to right-click, Create New, Folder. I might create an object called Models, and in here, make another subfolder called Console. Select a folder, and it will now extract that material and put it within the folder. I'm going to drag my object into the Models folder as well, and into the Console folder. Now I need to bring my textures into this. Find my Textures folder, go to Console, and I can drag my textures into here. If you'd like to, you can right-click and create a Textures folder just for this object. And it's up to you. You can either keep the material in the same hierarchy as the other objects or put them under the separate Textures folder, whatever works for you. Here we have the console. I'm going to click on the material now, and we need to link up the different channels. So here I'm going to go to under Textures, but you'll notice when I switch between these, because they're in different locations, I have this problem. One way to get around this problem is to select the object, click on the lock button at the top, and then go finding your textures. And then now we can click and drag, and we don't have to worry about things switching on the inspector side. Metallic smoothness, click on normal to normal map, hit Fix Now, and we can see our object here. Now I kind of want this object to beckon the player without me having to do any additional work. And what I mean by that is I don't want to have to add a silhouette or a highlight. So we're going to create a quick script, and it's going to change the emissive value of this object. Come back over to Textures. You'll notice we have this emission map. By default, under console_m, emission is turned off. We need to add that. If you do not have emission off, the shader system inside of Unity assumes that you didn't want it, so it doesn't include that code in the compiled shader. Therefore, even if you make changes to emission, nothing will happen. I want to click on emission. I want to drag that over here. Now, the reason I made the emission map black and white is because I want to utilize the color here to choose what value it will be. Maybe in some circumstances, I want it to flash green when things are healthy or after you've done the right thing. But at other times when things are bad, I want it to choose some form of red. Since colors multiply by component in most color manipulation algorithms, I can depend on that to be able to change how this works. Now, the last thing you really need to make sure you do is, under emission, go to global illumination and change this to real time. Baked means it will bake, when you do a light baking, that emission information, but we want this to pulse and glow in real time. Failing to change this option is probably the #1 reason most people can't get emission maps to properly show up. So now let's go to our console folder, right-click, create. I'm going to create a C# asset. And let's just call this console. On console up here, I'm going to go ahead and unlock this so we can see it and drag this script here. I'm going to double-click the script to open it. For this console to work, I need to manipulate values in the emission portion of the shader. If we select our console_m, come up here to this little widget, hit select shader, we get to see all the property names that we can manipulate. Here we have _emission color. So we want to grab that value. You can do this as a string if you want to, but if you're going to be making lots of changes rapidly across many objects, we should try to be more efficient than that. We can actually bind to this particular property by using a function in the shader class. First, we need to create an integer value. So let's do int. In this case, I'm going to put a b underscore at the beginning just to indicate that I'm binding to something. You can use whatever convention you want. And I will call this _emission color is going to be equal to a -1. If you have -1, you know you didn't get that texture. Now under start, we need to bind to that. So I'm going to do shader dot property to ID. I'm going to first pass in the name of the ID as it is over here. So we can just type in _emission color. And we are going to set this equal to our variable there. Now we know what index this particular property has been assigned. Now I'm going to want this value to pulse. We could use coroutines. We could animate it if we wanted to by using an animation controller. In this case, though, to make this video short, we're just going to update. To change this value, we're going to need access to the material. So let's go ahead and create a material. Mat is equal to null. Then down here, I would like to do mat is going to be equal to this.getComponent, and the component we want is the mesh renderer. We may want to require a mesh renderer when we attach this by choosing require component, type of, and then saying mesh renderer. When this script is added to any future component, it will automatically add a mesh renderer object to it. So here we've grabbed this.getComponent mesh renderer. However, what we really want is the material associated with that object. Now at surface level, you might think this will work, but let's take a look at our hierarchy. We have the console fixed scale, and on top of this game object is our console. However, it's actually under this object that we have the button, the lever, the slider, and the slider body. Therefore, if we try to get a component, we're only going to be getting this console. And as you can see here, if I turn that mesh renderer on and off, we won't be affecting any of the other elements. What we really want to do is specifically get the parts that are going to have emission controls, such as this one up here and this one down here. While it might look within the editor that you only have one instance of this material, the reality is that for each game object, when you press run, it's going to create an instance or a clone of that material. And when you modify that specific clone, none of the other ones will be modified along with it. So we need to be careful. This way of doing it is not going to work. And because we have multiple game objects, all with their own copies of that material's instance, we're going to need to have an array. So here, instead of material mat, we could do either a list, like this, list of materials called mats, and we can make this a new list of type material. So we have a new list of materials that we're going to have. This could also be an array if you'd like. Here we have mat is equal to this.getComponent. Instead of that, let's do this.getComponent get components, you notice it changes, in children. Type mesh renderer. And this will grab all of those objects. Now what we want to do though is specifically we're interested in the material. Now this will return an array of these values. So we need to make sure we have the appropriate variable to store that. So let's just do mesh renderers, and we'll make this an array of objects. Mesh renderer array. Now we can iterate through these objects and shove them into our list if necessary. We can do for each mesh renderer mr in mesh renderers. So this is going to iterate over each element within that array. Now we can choose mats.add if we want to, and we want to add to this mr.material. And now we've gotten all the materials for all of the sub-objects and the object itself that the script is on inside of this. Now let's create a function that's going to automatically update all those materials for us in one pass. So let's do void update emission. We'll pass in a color, and all this will do is it's going to iterate over all the elements stored within mats. So we can do another for each loop, except this one will be over mats, and we'll be working with materials instead. We'll do mat in mats. Now we'll do mat dot set, and we want to set a color. We're going to pass in the ID that we stored earlier, which is b_emission color. Or you could put an ID at the front. It's entirely up to you what convention you want. And now we just pass in our color value to that object. Now with an update, we can call this method to continually change our color value. So let's make this a little more interesting and create two public, or this time we'll use serialized field, so it's not public. We can call this color start, and we can do equals to color dot, let's say it starts as green. We'll do color end is going to be equal to color dot red. Then down here in update, we can just use a lerp to do the rest of the work. So if we do color dot lerp, we can pass in color start and color end. And we just need a value t that goes between 0 and 1 to bounce between the two. Of course, we can just use our old friends mathf dot sine and cosine. And in this case, we'll do sine of time dot time since level loaded is what I'll be using. And we'll set float t is equal to that value. Time since level loaded will continue to increment as time progresses. So there's no reason for us to deal with storing the current time unless you need to operate differently from the time in the level. So with this, let's come back over to Unity and hit run. And we'll zoom in on our scene view and take a look at what's going on. And I'll choose shaded mode. Now nothing's happening. So let's take a moment and try to figure out why. Let's open up our material after we have the object selected, maybe this lever arm, for instance. And what we'll notice here is that it's set to real time, and we do have a value here, but it does not appear to be changing. So what happens if we decide to change this value? Well, notice here that as I'm moving this around, this object is changing, but this one isn't. And more importantly is, notice that it's console_m, but then in parentheses is the word instance. Remember, this is why we took time to grab each one separately. These are different instances of this material. It is not this base material anymore. So even if I go in here and make changes to the material, none of that is propagating to the instances that were generated. I'm going to turn that off for a second. Now sine is going to bounce between -1 and +1. mathf.abs for absolute value so that we don't get any negatives. Now this is going to jump from 0 to 1 and then back and then quickly go back up to 0 to 1. Bink, bink, bink. Almost like a ball bouncing is what we'll be getting for our t value. Now we just need to call update emission, and we'll pass in the value we get from lerp. So we can do a color, temp color is equal to this. Put that in there, semicolon on the end, and hit save. Coming back over to our Unity scene, and let's just set the default color to something wrong so that we know it switches when appropriate. Let's hit run and go over to scene view and take a look. And there we can see it. It's oscillating between these two values and changing. What's really important to note is that I have console M selected over here, and you'll notice that it's not changing. This is the material we created to define this object, but it is not the material being used at runtime. If we come over to lever, open up this material, we can interactively see in the inspector that this value is changing. We can do the same thing for slider. We can see that value changing as well. And notice it says console_m instance. It takes the material you created and provides separate instances for all the different objects in your scene when you hit run. Therefore, we can modify every game object individually. And if I come to console_m here and I make changes to this, you'll notice that nothing in the scene is listening to it. This was used as a template. Now each of these objects has its own instance of the material and is operating independently. That of course means we could, for instance, come up here and we could have assigned this script to separate components of this object instead, and then given them their own unique on and off values for color start and color end. So coming here, if we change color start, we can interactively see it using that color start value and then ramping up to red and then going back. Now the last thing I'm going to do in this video is, you'll notice that the slider and the slider body are separate objects. This is fine, but you may want to include one within the other. So even though we didn't parent-child these over in Blender, it doesn't mean you can't make any changes to your object in the scene. I can click and drag slider to go under this object. Now it's going to yell at me and saying you can't do that directly, and that's because I haven't created a prefab for this object. That is, a prefab stores the game object. It's not the mesh, it is the game object, its components, materials, and so forth, and all the connections inside of Unity you have established. If you want to keep an object and reuse it over and over again, you should be making prefabs. So I'm going to go to Models, Console, right-click, Create. I'm going to create a prefabs folder. Whether or not you have a prefabs folder within each separate model, or you move this into the models bin itself, or prefabs is completely outside of models, this way, if you have someone working on your team who's ingesting the models, they stay in the models folder, and the person working on level design and only within Unity can just stay in the prefabs folder. I'm going to click and drag this into this area, create an original prefab. You'll notice the icon is now changed. It is not that little divot in the center indicating that it's a mesh. Instead now we're working with a prefab which has this box icon and is blue. Now with a prefab, we can go and make any kind of modifications we like. I can click that slider, move it under the slider body, and it will say, hey, wait a second. If you want to do this, let's open up the prefab and make changes over here. Within this mode, you've isolated the prefab itself from every other object in the scene, and now you can begin making your changes to this object, such as structurally moving the slider or making it some other location. Now you'll notice that we did have a little bit of an issue here. This slider, because we had ambient occlusion being baked with the slider in that location, it got burned into this object over here. You could go in there and remove it manually, you could go in there and rebake it. It's entirely up to you and how you want to fix something like that. But either way, once we're done, we can click here to go back to the scene view, and our changes are baked into the prefab as you see here, and they are shown in our scene. Now there's nothing stopping us from creating an entire wall of consoles. But once again, we probably want some form of snapping to make this an easy process. The snapping hotkey is the / key on your keyboard, but you might need to change how it snaps. Click here on this little grid looking icon, then ... and edit. Inside of here, you can change your grid size. So if I want to make it larger, I could do 1. This way I can make it so it snaps exactly 1 unit either way, and the extents of my object being 2 units wide will perfectly always line up on edges of things. And close out of this if we want to. And now you can begin designing your scene. Hit Control D, move this over, hit E, hold down Control, rotate these individually, and move this back into place. And now you can create a series of consoles all together. And because they're all prefabs and they're all using that script, I can hit Run now, and in our scene, what you'll notice is they're all lighting up. But they don't have to light up together. You do have control over each one individually. You could create a master script that iterates over every single one and modifies the start color for each one. So if you wanted them all to be updated based upon maybe something strange going on in your level, or maybe each one of these consoles pertains to a different part of a railroad track, you'll notice now that each one is updating with their own independent colors. And that's it for bringing the console into the scene, setting it up with a very simple script, and making sure the materials are properly assigned to the object, as well as the textures assigned to the proper channels within the material.